Now let's take a look at second order differentiations, turning point, and maximum or minimum points. So what is second order differentiations? So first order differentiation is dy. Okay, first order is dy dx. So second order is d square y dx square. So basically just differentiate dy dx again, then we'll get second order differentiations and turning point. In this subtopic, turning point meaning dy dx equals to 0, meaning the gradient is equals to 0. So maximum minimum point is max or mean point is d square y dx square. Okay, when the second order differentiation d square y over dx square is bigger than 0, is a minimum point. When d square y over dx square smaller than 0 is a maximum point. So meaning this minimum point over here is over here. One easier way to remember this one is when you have bigger than 0, you have a small face. So this is a graph. So this is a minimum point. When you have less than 0, second order differentiation is less than 0, you have this sad face. So that's why this is a maximum point. So let us take a look at one example. Y equals to 4x cubed minus 5x squared plus 6x plus 3. 6x plus 3. We are asked to find the second order differentiations. So first, we dy dx first. Okay? dy dx. 4x cubed we get 12x squared. Minus 5x squared we get 10x. 6x we get 6. 3 we get 0. Okay? So second order d square x dx d square y over dx square. Differentiate this one, we got 24x minus differentiate 10x 10. 6 become 0. Now let's take a look at this example. Given by questions y equals to 2x cubed minus 4x squared plus 3. We are asked to find the turning point and determine whether the turning point is a maximum or a minimum point. So first, Let us get a dy dx first. dy dx. Differentiate 2x cubed is 6x squared. And this one we get 8x. 8x and 3, 0. Okay? So turning point meaning this one equals to 0. So simplify it. 2x, we take the 2x out, become 3x minus 4 equals to 0. Right? You just take out the 2x over here. So it become 3x minus 4. So there will be two solutions for this. So when first this one, x equals to 0. Second, x equals to 4 over 3 from here. Okay? This 3x minus 4, make it become 0. Then you get 4 over 3. X equals to 4 over 3. So when x equals to 0, y equals to, substitute 0 in here, we get 3. Okay? This one. So 2 multiply 2x cubed. Substitute 4 over 3 inside. Minus 4x squared. Plus 3. And this will be 17 over 27. And how do we know whether this one is a maximum or minimum point, or this one is a maximum or minimum point? Now we get this one. Second order differentiation, d squared y dx squared. So differentiate this one. So we get 12x minus 8. Okay? So here, use it over here when x equals to 0, then d square x or d square y dx square equals to, substitute 0 into here. We got 12, 0 minus 8 equals to negative 8. This is a negative. Negative, what kind of phases we get? I mean, what kind of point we get? Maximum or minimum? Negative is maximum. Remember, when you get negative, you have a set phase. When it is set, it's a maximum point because over here, right? And then when x equals to 4 over 3, so d square y over dx square, substitute 4 over 3 in here. Sorry, 4 over 3 substitute inside here. So we get 12, 4 over 3 minus 8. Okay? 1, 4, 16 minus 8, and we get 8. So 8, this one is a minimum point. And when you get positive number, what kind of phase you get? Happy. And this is the graph. Minimum point. Now let's take a look at this example. Given by the pressures y equals to ax squared plus bx plus c. And this graph, it has a turning point at minus 2, 4. And also this graph passes through 0 and 12. Right? So we are asked to find the value of A, B, C. So how do we find it? Okay, first of all, we use this point 0 and 12 to find point C. Why? Because when x equals to 0, this term and this term becomes to 0. Then we can find C. Okay? So passes through 0, 12. So we substitute in it. So y is equal to 12. 12 equals to A multiply 0 plus B multiply 0 plus C. Therefore, C equals to 12. Okay? Then turning point at minus 2 and 4. So how do we get turning point? Using dy dx. Okay? Differentiate this y. dy dx equals to 2ax plus b is equals to 0. Right? Turning point. So write this way. So at turning point minus 2, 4 dy dx equals to 2ax plus b equals to 4 or equals to 0. Then we substitute into minus 2 into this x. Okay? Maybe we should write this way. dy dx 2a x negative 2 substitute into x becomes negative 2 plus b equals to turning point is gradient of turning point is 0. So this will be 2 multiplied negative 2 negative 4a plus b equals to 0. We name these equations number 1. And then how do we form another equations for this one to solve it simultaneously? Okay, turning point. Just now we substitute this 0 and 12 into these y equations, you get C. Now let us substitute negative 2 and 4 into this to generate another equation so that we can solve it simultaneously with equation number 1. So passing through minus 2, 4. So substitute in it, y equals to 4. A multiply negative 2 square plus b multiply negative 2 plus c is 12. So 4 equals to 4a minus 2b plus 12. Move everything to the left hand side. We get 4a minus 2b plus 8 equals to 0. We name it equation number 2. So we have 1 and 2. We equation number 1 plus equation number 2. Why we plus? Because we want to cancel out a. Negative 4a plus 4a is 0, right? So b plus 2b plus negative 2b will be negative b. Okay? So any constant here? No. So it will be 1a equals to 0. Therefore, b is equals to 8. Okay? When b is equals to 8, we substitute into equation number 1. Okay? So when b is equals to 8 minus 4 a from here plus b is 8 equals to 0 over here. So it will be minus 4a plus 8 equals to 0. 4a equals to 8. A equals to 2. So value of a is 2. Value of b is 8. And c is 12. And if you have any questions regarding this subtopic, feel free to comment below this video and we will further explain it to you.